Hello everyone. Today we are going to talk about addition of the vectors. We know vector is a physical quantity who is having both magnitude and direction, and it can be represented as components of a vector. Say for example, you can say a vector a bar is having a component along x-axis. To say it is having a component along x-axis, that component is multiplied with a I cap, where I cap is a unit vector along x-axis. Therefore, ax I cap together says that it is along x-axis. Similarly, so it is having some y component, multiply with a j cap to say that it is along y-axis. It is having some z component, multiply with k cap. Now, assume there is another vector b bar that's having components like bx I cap, by j cap and bz k cap. Earlier we have learned about the mathematical addition of the geometrical addition of the vectors, like by moving tails and heads of the vector by shifting a vector parallelly. But now we want to do it in an algebraic way. So I want to say there is a vector a bar, there is a vector b bar. I want to add. As these two components are along x-axis, this is not like a addition of the scalars that just add like anything, because vectors are having a direction. We need to take care of the direction also while we are adding the vectors. So add in such a way that components along the x-axis has to be added together, ax and bx together with I cap. Components along y-axis also has to be added together, ay and by together with j cap, and components along z-axis has to be added together along k cap. So when we are adding two vectors algebraically, we have to add their x components, y components and z components separately, and that gives rise to a particular kind of a vector. Say for example, if somebody say a bar equal to 2i bar plus 3j bar, b bar equal to 3i cap minus 4k cap. Now I want to add a bar plus b bar. Now I have to add I components, that is components along x-axis, 2i and 3i. It will become 5i cap. 3j, but there is no component of the j in the second vector, therefore it is going to be 3j cap. There is no k component in the first vector, but there is a component of k in the second vector which is along the axis, 4k cap. So this is how we are going to find out addition of the two vectors. Even the subtraction also will be the same. We are going to follow the subtraction in the same way. That means we will subtract the components along the same direction and add a direction of that particular component. So the subtraction is also done in same way. Suppose I just want to try a problem, therefore we can understand what I mean by this. Say for example, if somebody say a man moves 10 meter east, then 10 meter north, and then 10 root 2 meter northwest. What is his final displacement? If this is the question, what is his final displacement? So I want to solve this problem using the vector addition. Let us first try to picturize what he is saying in the format of a graph, and then we will try to solve the problem. This is the coordinate system that we have: origin, x-axis, negative x-axis, y-axis, negative y-axis. So it's very clear. If I have to show something along x-axis, I have to multiply with plus I, negative x-axis minus I, y-axis plus j, negative y-axis minus j, so that we are assigning a proper direction. What is given in the problem is he is moving first 10 meter east, something like this. This is the first vector, say A bar. I would like to say A bar 10 meter east. East is along positive x-axis, so I will call it like 10 I cap. Then he has moved to some other direction 10 meter north. So let us try to show what do you mean by the 10 meter north. He is going like this. This is his B. From the origin I am taking, so that we will be knowing the directions, because anyway I am not solving basing on the graphical method. So I would like to say B bar as 10, north is a positive y axis plus j. Then he has taken a third direction, that is 10 root 2 north and west. So this is east as per our graph, this is west, this is north, this is south, and he is in between north and west, exactly in between north and west like this. This is your C bar. He is making an angle say 45 degree because it's northwest. Now because it is in between x-axis and y-axis, we need to resolve that into components. So how we are going to resolve this? As the vector is starting from the origin going away from the origin, its components also shall go away. This is how the component Cx, the y component also shall go away. Component shall have the same direction of the vector. So I would like to say Cx is, C is Cxi cap and Cyj cap. It's very clear that actually this is not plus I cap. Why this is not plus I cap? Because it's along the negative x-axis. In fact, I have to say Cx minus I cap. Of course, Cy is along the positive y-axis plus j cap. What's the value of the Cx? It's along the x direction, so it's cos component. C cos 45. That's nothing but 10 root 2. Cos 45 is 1 by root 2. That's nothing but 10. And Cy is along the y direction, therefore it is sine component. C sin 45. That is also 10 root 2. C sin 45 is 1 by root 2. So that's value is 10. So I can write C bar as plus 10, that is Cx, but minus I cap because it's along the negative x-axis, and plus 10 plus j cap because it's along the positive y-axis. Now I want to find out the resultant displacement of all these. I have to simply add them like vectors. A bar plus B bar plus C bar. I know A bar is 10i, B bar is 10j, and C bar is minus 10i plus 10j. So it's very clear from this that I components gets cancels. What's remaining for us is nothing but equal to 20j, because I components got cancelled, right? So what's the answer is 20j. J cap. That j cap is a way of telling you that it's having a direction of the north. So the resultant of that is displacement is 20 meters and it is along a direction of north. This is how we are supposed to add the vectors using the vector algebra. Thank you.